Hello, I'm Martin Maiden, and it's my pleasure to welcome you to this PubMLST showcase event, where we will be illustrating some of the developments we made on PubMLST with a combination of talks and question and answer sessions that will enable you to delve a little bit deeper into the facilities that are available on this open access web-based platform. Just to summarize how we're going to run this session, which will be recorded, and welcome if you're watching the recorded session after the live session is finished. This will be available on the web. After my introductory remarks, we're going to have two different sessions of the event. Firstly, the core development team of Keith Jolly, James Bay and Margaret Varga will be talking about their particular elements that they have developed within the platform. Then after the short break, we will have a number of external speakers headed by two members of our scientific advisory board, Heather and Sylvain. We can't be joined today by Kat Holt, the third member of the board, independent member of the board, because of the very pleasant reason that she's taking maternity leave for her first child. So we wish her all the best. Yvonne, who will be talking about the chlamydiales, is a long-term collaborator who's used PubMLST to explore that particular group of organisms. Then Charlene from my group will be talking about, she's a clinician, and she'll be talking about translating microbiology into the clinical setting. Melissa, currently working with Angela Brueggemann, but who was with us, is going to be talking about their work on pneumococcal genomes, and then Angela will finish the meeting with a discussion of the IRIS initiative and how she's used PubMLST to support an international network. We have just give you a very brief history of the PubMLST website. This has been published, so I won't go in any great detail. Obviously, this started with the development of the MLST schemes in the late 90s. MLST is famous for being a typing scheme, but it was always intended as a population genetics approach. So I like to think of it as population genomics 1.0, if you like. But we very quickly realized when we developed that we needed to have web-based universal nomenclatures. And so the first MLST scheme, site which I designed, which was a bit of an embarrassment when looking at it today, was available straight away with the primers and the alleles that were defined in that first paper. Obviously, we've come a long way until then, and this timeline has been illustrated in this paper that Keith, James and I wrote a couple of years ago. Obviously, since that time, there's been an enormous growth in sequence data, and specifically genome data, as a consequence of developments in sequencing platforms. And this is sort of the slide that one shows, one updates every time with this enormous growth in data. What's perhaps noticeable is that there's still a large number of isolates in the PubMLST database that don't have genome sequence data. I personally believe, particularly in the clinical setting, we are not going to have genomes for everything, so we need to be able to accommodate all types of sequence data. So PubMLST has always hosted single locus data, multi-locus data, complete genomes, and everything in between. And of course, the value of this data is hugely improved by it being curated, it being of good provenance, and also knowing about the provenance and phenotype of the organisms that it's come from. In other words, where they come from, what they do, what people call metadata. So at the heart of PubMLST is the BIGSdb platform. Again, this is being published and reviewed, but just to summarize, we have a community of users, and this community is very large. Tens of thousands of people use the website. And within, but that community is not just users. Within that, we also have people who submit data, and a smaller number of people who are curators. So we have hundreds of curators, thousands of submitters, and perhaps tens of thousands of users. At the heart of the PubMLST, as I said, it's the BIGSdb software, which was designed specifically to do this, and that combines sequences of all type up to whole genomes, the provenance phenotype metadata, and the annotation. Importantly, we link to other resources that are publicly available, and we make the data available both through the web interface that we'll be talking about today, but also through the third-party analysis sites who can use the API, which Keith will be talking about later. Although, as I say, PubMLST is much more than typing. Typing is, of course, at the heart of it, because biology depends on accurate classification, and microbiology particularly. And in 2013, we proposed this schema of how one can think about how MLST fits in with. And the more loci they use, in any kind of typing scheme in general, the higher the resolution. Obviously, particularly with the popularity of microbiome studies, 16S is still widely used, but it has rather limited taxonomic resolution, down to the genus level, sometimes to the species level. 7-locus MLST works very well for species, and I personally think for genera in particular, and within species can define down to lineages, clonal complexes for most species, not all, with as few as 7 loci, which is a reflection of the strength of population structure in microbes. But unfortunately, we can't really look at schemes outside of genus because the MLST genes, metabolic genes, are just too variable. However, the introduction of genomics enabled us to devise ribosomal MLST, which James will be talking about, which enables us to cover a much wider range all the way down really to substrain level. However, ultimate resolution, if you're interested in an outbreak or very fine differences, you have to look at many more loci, and maybe up to the whole genome or core genome of all those genes present in the vast majority of isolates, and that's possible too. All of this can be realized within the PubMLST platform with appropriate nomenclatures. So, as I say, we can combine a whole variety of different types of data that we can submit into the sequence bin where it's stored. We can index those sequences, link them by a process of annotation, what I like to call population annotation. So every locus of every member of a population can be annotated and defined and combined together for a variety of different applications, evolutionary analysis, looking at AMR, typing, linking to phenotype export, and exporting the data for external analysis through the API, giving us a range of different functions. And again, we've published this as, if you like, the gene by gene population genomics approach, which has been adopted widely by others as well. PubMLST has another important element, which is what I like to call the 3 Ps. Although our ambition has always been to have the data completely open access and as freely available as possible, we do realize that for various reasons, people cannot always publish their data immediately, and this is what I call the 3 Ps. It might be to do with privacy, GPDR reasons, epidemiological analysis, commercially sensitive reasons with food outbreaks, for example. There's a whole variety of reasons. PDFs or publications, obviously people's careers depend on publications, and you can't necessarily expect them to make their hard-earned data available until they've assured that they've extracted a sufficient publication from it, and of course patents. So by having an ability to store data privately in the database, that means that you can analyze your private data in the context of public data and then hopefully publish it when the time is right. You need to have a user submitter privileges for that. You have to have a user account, but it's entirely possible. And the data always remains, if you're the submitter, in your control as a submitter, and it's the submitter's decision, your decision, if you have to be the submitter, of when or not you publish it. So this gives you an idea of the range of applications we can use and the users. So everybody from epidemiologists, clinicians, researchers, taxonomists can all provide a variety of tasks. They can look at surveillance, outbreaks, maybe clinical management, vaccine development, evolutionary analysis. All of these types of studies can then be combined by a variety of different methods, which we'll be learning some about today. And there's a lot of different tools. Some of these tools are built into the PubMLST software, and others of them you can access using the API, or indeed other software can use the API to come in and get the data from PubMLST. So we're very fortunate. We've had continuous funding since 1997, and that will go on now to 2004 as a consequence of the Wellcome Trust Biomedical Resources Grant. The software and data are all open source. Nothing about it is proprietary. You don't need a special license. If the data is on the web, you can use them. And if you wish to use that BIGSdb software, that is also available on GitHub. We have a wide range of external collaborators, Sylvan being a major one, and the CDC, who Heather is representing today, Endro-based, Pathogen Watch, and Pathogen Tracer all work with us. And of course, we're very grateful to the Wellcome Trust for this lasting funding. So just to conclude before I'll let the other talks progress afterwards, I'd like to thank all the members of my lab, past and present, who've made these tremendous work possible, and many collaborators, which have been an enormous pleasure to work with. It's one of the great things of doing this is we've been able to work on many different organisms, and there's a very large number of schemes available on PubMLST, which you can go and see. And that behind that is an indefatigable army of curators. And one of the aspects that I'm most pleased about in the redesign of the site is that we are able show exactly who they are and what they've done. So that's tremendous, and a big shout out. Thank you very much to them. And apart from the welcome, we've been funded by a range of funders over the year. And thank you for your attention, and enjoy the rest